All right, guys, welcome back for the second piece of our first technical video, all about hardware and data storage. So we talked last time about the pieces of a computer and how those things work. Now we're going to talk about data storage, right? How we permanently store data. So first I got to talk to you a bit about binary. Okay, binary, a lot of people get confused when talking about binary, but it's actually a very, very simple process, okay? And to give you an idea of how this works, I'm going to talk to you a little bit about math and how math works, okay? So when I write a number like 154, we all think of this as it's very easy to understand what I mean when I write out this numeral, right? Because we use the decimal system as humans. Basically everywhere in the world uses the decimal system, which means base 10, right? And we just kind of know what 154 looks like, even though we don't think about why we know what this means. We just know what it means because we're so used to it, right? But if we really think about what this means, what we're saying here is, you know, there's a 4 on the right, then a 5, then a 1. And we just know from experience that this means 154. But when we really think about it, that means 4 in the ones place, right? So 4 times 1, right? Plus 5 times 10, right? Plus 1 times 100. So that's 100 plus 50 plus 4, right? And because we're so used to the decimal system, that makes sense. A base 10 number system very much makes sense for humans. But with binary, we don't use base 10, we use base 1. So let's do a number like this, okay? We're going to do the exact same process, but instead of 100 plus 50 plus 4, right, we're now working in binary, which is base 2, okay? So we have a 0 in the ones place, but a 1 in the twos place, a 0 in the fours place, a 0 in the eights place, and a 1 in the 16ths place, okay? So what that means is instead of 100 plus 50 plus 4, we have 2 plus, what was it? 1s, 2s, 4s, 8s, 16s. So 16. So what does that mean? This is 154, right? So 2 plus 16 equals 18. So this right here is the number 18 in binary. Does that make sense? So it's just this many times 1, this many times 2, this many times 4, this many times 8, this many times 16. And then if we had a longer number, it would be this many times 32 and this many times 64, right? So whereas we go up by 10, 1, 10, 100, with decimal, we just go up by 2 with binary, 1, 2, 4, 8, etc. Does that make sense? Please post comments in the video section if this doesn't make sense, all right? But let's get back to this. So 1 bit of data is either a 1 or a 0, right? That is 1 bit. 8 bits go together to make 1 byte, okay? So let's go back to this. If we have 8 numbers, right? Let's just call it 8 ones. 1, 2, 3, 4, 5, 6, 7, 8, okay? That's a 1 in the ones place, plus 1 in the twos place, plus 1 in the fours place, plus 1 in the eights place, plus 1 in the 16s, plus 1 in the 32s, plus, wait, let's see, 1, 2, 4, 8, 16, 32, 64, 128. 128 equals, anybody know what that equals? Equals 255. Now, 255 plus 0 is a total of how many different numbers? 256. And that, all of these numbers, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, all those numbers, those are the nice round numbers for a computer, the way 100 and 1,000 and 10,000 and 100,000 and a million are in decimal. Okay? Now, so I've got this funny little cartoon. So this is 1 hobbit, and 8 hobbits equals 1 hobbyte. Get it? Because remember, bits are 8 bits to 1 byte. Yeah, that's funny. And there are 256 different values that 1 byte can have. 1 bit can have 2 different values, 0 or 1. 1 byte can have 256 different values. Okay? So, how do we permanently store these bits and bytes and kilobytes and megabytes of data? Well, early hard drives look like this. This guy found this old hard drive in a barn somewhere. But essentially, these are vacuum tubes, and it would store data on these rolling drums. And this was a very old form of permanent data storage. Luckily, we don't use any more like, I mean, I would be surprised if this could handle 1 kilobyte. Like, that's, you know, that's how old this thing is. Based on kind of the time period when it's from, this is, you know, a few kilobytes maybe. All right. This was 50, more than 50 years ago now, but this is a hard drive, and it stored 5 megabytes. All right, which is not a lot of data. And this today stores 2 gigabytes worth of data. So it's just showing you how this has shrunk. Data storage has gotten way better over the years and continues to get way better. This is an internal hard drive. So this is kind of one of the early internal to a computer hard drives. Then they got smaller and smaller and smaller and smaller. This is a modern laptop drive. This is a modern desktop drive right here. This is what a modern Platter style hard drive looks like on the outside. Okay, it's 3.5 inches, I think, by 5 inches or something like that. And modern drives are usually, you know, a brand new top of the line modern hard drive will be a few terabytes. Okay, if you're watching this and it's been a few years, that you might be laughing and be like, oh, only a few terabytes, ha 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 ha. But in 2019, it's a few terabytes can fit on 1 hard drive. If you open that up, however, it looks like this. All right. Now this is the Platter, and this stores the data. And you'll notice that this one has what, 5 platters all stacked one on top of each other. And these spin when you turn your hard drive on. This starts spinning at somewhere between 5,000 and 10,000 RPMs. So this thing is zooming. I mean, it is going, right? This thing right here is the seeker head. And this kind of can swing back and forth. And as this spins around any different place on this hard drive, it will be able to kind of move this head and cover that spot. And it is responsible for both writing 1s and 0s and reading 1s and 0s that have been previously written. Okay? And this does not touch the Platter as it's spinning around at 10,000 RPMs, but the distance between the seeker head and the Platter is minuscule. It is measured in fractions of the width of a human hair. So while they technically do not touch, it is really close. And in fact, one of the big problems with this kind of hard drive is if it's spinning at 10,000 RPMs and that seeker head is so close, and you accidentally bump your computer, you could jostle it to the point where the seeker head actually touches the Platter. And when it touches the Platter, it's going to scratch. And when it scratches, any data that was stored in the places where that scratch happens is now gone. So you can lose a lot of data real quick, or in fact your entire hard drive if you scratch the wrong part of it, if you jostle these things too much, which is very difficult for laptops with a Platter hard drive. So one of the things they've invented recently is the solid-state drive. Solid-state drives are essentially just giant glorified USB drives, but they're designed to be permanently housed inside your computer. Now, the good side of this is that there's no moving parts, so it doesn't wear out, it doesn't break down nearly as often, and it's much faster. These solid-state drives are way faster than Platter hard drives. The downside with these things are they're much more expensive. Just the cost for one of these things monetarily is much higher than it is for a Platter hard drive. The other downside is they're usually they hold much less data. Okay, so whereas a Platter drive, you can get a cheap one that'll hold 1 terabyte. A solid state drive, you're going to be spending way more money for 100 gigabytes, which is 1/10 the space. So you need so while they're faster, they last a lot longer. They don't wear out. You're going to pay a lot more for a given amount of data storage. But most of what we're going to talk about is with the old school Platter hard drives rather than one of these. So they store data magnetically, right? Because if you think about it, a binary is a 1 or a 0, right? It's a binary state. It's yes or no. It's on or off, right? And magnets have a very interesting property in that it's either magnetized or it's not, right? So it's either a 0 or a 1. There's either the magnetic imprint there, which can represent a 1, or there's not, which represents a 0, right? So both the platters are stored things magnetically, which means you really want to be careful with magnets around your computer, because if any kind of powerful enough magnet gets close to a computer hard drive, it can completely, turn all of the sectors of that hard drive to 1s, for instance, right? And if you just have 1 1 1 1 1 1 1 1 1, that's not actually storing any information. It's wiped out all the stuff you had stored there. So you need to be very, very careful with magnets around your hard drive. Essentially, when you get a brand new hard drive, the first thing you need to do is create what's called a partition on it, okay? Different kinds of there are rules for how data is stored on a hard drive. There are different kinds of these sets of rules. The most common for Windows systems is a system called NTFS. Okay, NTFS is a file system, and it just dictates the rules about how data is stored on that hard drive. The Macintosh operating system uses a different file system. It uses what's called HCFS. HCFS and NTFS get the same job done. They have a set of rules about how data is stored on that drive. But they're different and they're not cross-compatible. Meaning if you have an HCFS partition, you can't store NTFS formatted data there. So the first thing you need to do, you get a brand new hard drive, is you need to tell it which system of rules it's going to follow. If you've got a Windows machine, it's almost definitely going to be NTFS. And with every particular hard drive, you're almost definitely going to say, this one physical hard drive is going to have one partition on it. You're going to say, this entire hard drive, every single sector of it, all of it's going to be one partition, and I'm going to call that partition NTFS. And now every time data is stored or retrieved, the computer knows the rules for how data is stored and where it's stored, and it will follow that set of rules and thus understand what data is on there and what's not on there and when to start and when to stop. Okay? You do not have to have one partition per physical hard drive. There are reasons and there are some situations in which you might want 2 different partitions on one physical hard drive, or 3 or 4 or 5 or 100. You can do that if you want. Okay? You can say this partition is this section of the hard drive and it's going to be NTFS. This other section of this particular hard drive is also going to be NTFS, but it's a different partition than that one. And this third partition is going to be different than the first 2, and it's going to be HCFS. So you can divide, if you want to, for whatever reason, your one physical hard drive into as many partitions as you want. The vast majority of the time, you're just going to be one physical hard drive, one partition, but you can split that physical hard drive up into separate partitions, either all using the same file system, all using different file systems, whatever you want. But your computer will see that as different kind of devices, right? So if you pull up your computer, your Windows Explorer right now, and you go into My Computer, you'll almost definitely see C:. That is your main partition, right? If you put more than one partition per physical drive, you're going to see, on Windows Explorer, it's all going to be different. So if I put 3 partitions on one drive, one of them might be C, one's D, and one's E, right? Now, you can also go the other way, and you can take 2 or more physical hard drives and create one giant partition out of them, essentially. And this is essentially what's called a RAID system. And there's lots of different ways to set up the RAID, and there's lots of different benefits to different kinds of RAIDs. But essentially what they're doing is taking multiple physical hard drives and turning them into one partition or one logical device that your computer sees. So one way to set up a RAID causes you to read and write twice as fast, right? So it makes your hard drives much faster. Another way to set up a RAID creates fault tolerance, meaning if one of your hard drives dies, right? Because we've got moving parts, remember, with these old Platter hard drives, eventually those are going to wear out. They're going to die. They're going to get scratched. They're going to, just break because they're moving parts. They're going to break. One of the ways to set up RAID says that if any one hard drive breaks, no problem. You take it out, you put in a new one in its spot, it restores all that lost data, and you haven't lost anything. So a lot of archival computers where they're really worried about losing data, they really don't want to lose their data, they'll use this RAID system to make sure that if any hard drive dies, that's fine, they can replace it and they haven't lost any data, okay? But there's lots of different ways to do this RAID. But all of them are essentially using multiple physical hard drives as essentially one partition that your computer recognizes. Now, again, the vast majority of the time, one physical drive, one partition. But you can do multiple partitions per drive or multiple drives per partition, which is called a RAID. All right? Now, IDE and SATA. These are the ways to connect your drive to your motherboard, because data is going to have to go from that physical drive device, has to travel down a wire into your motherboard so it can be given to the RAM, and then from there to the processor and all those other things. The old system that you really don't see much anymore was called IDE, which looks like this. Okay, it's this big ribbon, and each one of these, there's like a bunch of wires in there, and they're all transferring data. The newer version, and what you see much more often now, is called SATA. Looks like that. Much smaller, much easier to handle, doesn't clog up the inside of your computer nearly as badly. And it transfers data much more quickly. So it's pretty rare to see these nowadays. These are going to be much more common. But this is just data from your hard drive to your motherboard. Okay? Now, here's what happens when you turn your computer on. The first thing that happens is your BIOS, which is on your motherboard, says, oh, hey, I'm a computer. I have a mouse and keyboard plugged into me. I know how those work. So I'm going to let my user use the mouse and keyboard, just as a basic thing. What other pieces of hardware do I have plugged in? Oh, I've got this video card. I should send all my data that I'm generating, all the screens that I'm supposed to be generating, out to this video card, and hence from there to the monitor. And then it says, oh, there's a hard drive somewhere in here. I have a hard drive connected to me. Now, if there are multiple hard drives, the BIOS has to say, okay, which one of you is the master hard drive, the one with the operating system on it? Now, an operating system is the software that runs all the other software on your computer. The most popular operating system in the world right now is Windows. Okay, Windows has a huge chunk of the end user market. There are other operating systems though. Macintosh has their own operating system. A very popular operating system for all the behind the scenes technical stuff is Linux, which is an absolutely free operating system, unlike the Microsoft and Apple versions. Linux is absolutely free, and it's much more customizable, but it is not nearly as user-friendly for beginners the way Windows and the Mac OS are. But then there are other, those are the big three for desktops. But for other devices, there's lots of other operating systems, right? So like if you have an Apple phone, your operating system is iOS. If you have an Android phone, your operating system is Android. There are different operating systems for tablets, and any internet-connected device needs an operating system, and it's just the software that allows all this other software to run. Okay. So the boot sequence says, where is the operating system? Oh, it's on this master hard drive. It's in this area of the hard drive. I'm going to start loading that into RAM. And the BIOS takes all that data from the hard drive that compromises the operating system and starts putting it into RAM. Once it's all into RAM, now your operating system can talk very quickly, remember, back and forth with the processor. This is the part where it says, you get that nice, if you have a Windows machine, that boot up noise, that right? And then it asks you to put in your password, hopefully if you have a password, which you should have a password. And you can log into Windows, and then Windows comes up on your computer, and it finishes the operating system loading process. Your computer will run really, really slow for, 10 seconds or whatever. But then once all of those operating system files are loaded from your hard drive into RAM, then you can start using your computer and everything's good to go. Does that make sense? All right. That is the end of this first section of our technical talk. Thank you so much for being here.